All right, these are notes for 7F, solving rational equations. So we dealt with expressions before, but now we're going to be solving equations that deal with fractions. All right, you will be taking these notes on your own paper. So here's some things we have to remember to check for. Check for extraneous solutions. Remember, that's a solution that looks like it works perfectly fine, but when you go to put it back in, something is undefined. Keep in mind the denominators can't be 0, so we're going to look at that first. We're going to look at our domains first. All right, the first example that we're going to do, we're going to solve a rational equation by cross-multiplying. You can only use this technique if you have a fraction equal to a fraction, a single fraction equal to a single fraction. These are probably the easiest types of problem you're going to have. All right, so take a moment, write down the problem. All right, let's talk about the domain first. What are we not allowed to have? Remember, our denominators cannot be 0. So that means to us, all right, let's look at this first expression. What's going to make that expression equal to 0? So 2x minus 5 cannot equal 0. So that means that x cannot equal 5 halves. So if we come up with an answer of 5 halves when we solve this, that's going to be extraneous because it's going to make our denominator undefined. Let's look at our second fraction. X minus 2. So x minus 2 cannot equal to 0, so x cannot equal 2. So if we come up with an answer of 2 when we're done solving this, we know that that's going to be extraneous also. All right, let's cross multiply. So we're going to get 20 times x minus 2 equals 5 times 2x minus 5. Don't forget to distribute the 20 and distribute the 5. So let's do that. Let's distribute the 20. Let's distribute the 5. All right, now here we go. Here's algebra again. We're going to solve the equation. So we're going to subtract 10x and get 20x. I'm sorry, let's try that again. Subtract 10x and get 10x. Add 40, and I get positive 15. All right, divide by 10. So we get 15 tenths. Let's reduce that by 5. And we're going to get 3 halves. All right, so now look, 3 halves. All right, make sure that's not one of our restrictions. Our restrictions were 5 halves, which is not 3 halves, and 2, which is not 3 halves. So that means our solution is 3 halves. And here again, any equation, and I will show you in class how to check this on your calculators. You can always plug them back in, but I'll show you how to check it by graphing. But always take the time to check an equation because you should know if the answer is incorrect or not. All right, there's an example of cross multiplying. We'll have some more at the end where you can practice. All right, let's do one that's not a single fraction. All right, first of all, let's think about back just this, when you were solving equations back in Algebra 1, how to handle something with fractions, because that's the same kind of technique that we're going to use when we solve these rational equations. We're going to multiply through and get rid of the common denominator. And this will work on any fractions, but it's especially useful when you have rational equations. So here, look that we have 3 and 5 are denominators. That means we have a common denominator of 15. Our least common denominator, 3 times 5 is 15. So I'm allowed, as long as I do the same thing to both sides of my equation, I can multiply every expression up here times 15. And what that does for me, it gets rid of that fraction. So I no longer have a fraction. All right, so let's do that. Let's multiply every expression up here times 15. All right, and let's simplify. So 3 goes into 5, 15. 3 goes into 15 5 times. 5 times 2 is 10x. Plus 9 times 15, 6 times 15 is 90. Equals, all right, 5 into 15 goes 3 times. 3 times 4 is 12. Minus, all right, 8 times 15 is 120. All right, notice that here we've gotten rid of our fraction. So now we can solve it All right, combine like terms and not have to worry about fractions anymore. That's the whole point of this, to multiply through by the common denominator to get rid of that fraction. All right, so let's solve this. So I'm going to get negative 2x is equal to, add 90, negative 210, divide by negative 2. So x is equal to positive 105. Okay? So like I said, it's just a technique that we're looking at here. We're going to use that same technique when we're solving these irrational equations. All right, so here's our first example. All right, take a moment, write that down. Notice we can't multiply, cross multiply here because this is not a single fraction. Now you do have the option of making that a single fraction and then cross multiplying, but I'm telling you that but that's going to be a method that on this one it's going to work pretty well, but in later problems it's going to get messy. So I'm going to show you a method that'll work for all the problems that we can't cross multiply. All right, so first thing we need to do is find a least common denominator. All right, so let's look at the different factors that we have. We have an x and we have a 3. And each appears at most one time in each expression. So that means our common denominator is 3x. All right, so to get rid of, so my whole goal here is to get rid of that common denominator, get rid of that denominator. So I'm going to multiply every expression up here by that 3x. So I'm multiplying 3x times 8, 3x times my 11 thirds, and 3x times my negative 14. All right, I'm going to write this out. Hopefully you're going to be able to simplify this as you go, but I want to show you what you've got here and why this is simplifying. So when I clean this up, I'm going to get 24x over x plus 33x over 3 equals negative 42x over x. Now see how each of those expressions can simplify? And when I do simplify, it gets rid of the denominator. That's my whole goal. When you simplify and it doesn't get rid of the denominator, then you haven't multiplied by the least common denominator. You're missing something. All right, so what do I get? I get 24 plus 11x equals negative 42. So now it turns into an algebra 1 equation. So now we're going to solve the equation. So let's combine like terms. All right, let's combine like terms. So I'm going to get 11x equals, let's subtract 24. I get negative 66. Divide by 11, and I get negative 6. All right, let's look. Now we remember we can get extraneous solutions. Let's go back and look at what we were not allowed to have at the beginning in our domain. All right, we've got an x in the denominator. That means x cannot equal 0. Well, negative 6 is not 0, so that is my solution, negative 6. All right, another example. All right, let's write this one down. Here again, notice that I can't cross multiply because on that right-hand side, there's two fractions. So I'm going to multiply through by the least common denominator to get rid of my denominator. All right, here nothing needs to be factored. You may need to factor to find your least common denominator, but in this case we don't need to. So I want each different factor, and they each only appear once. So that means my least common denominator is x plus 3 times x minus 4. All right, so that means each expression gets multiplied by that least common denominator. Only the numerator, though, because my whole goal, like I said, as long as I multiply, I do the same thing to each expression in my equation, I have got an equivalent equation. Alright, so we're going to multiply by the least common denominator. So this becomes 3x minus 5 times x plus 3, x minus 4 over x plus 3 equals 2 times x plus 3 times x minus 4 plus 8 times x plus 3 x minus 4 over x plus 3 x minus 4. Alright, I multiplied all the numerators by my common denominator. My goal here is to get rid of my denominators. Alright, that's a common. Alright, so now we get to cross out like expressions or like factors. So that means we can get rid of the x plus 3's, and we can get rid of the x plus 3's and the x minus 4's. My whole goal, like I said, is to get rid of the fractions, get rid of the denominators. So, alright, let's multiply back together what we have. So let's clean it. We'll see what we have left. We have 3x minus 5 times x minus 4. We have 2 times x plus 3, x minus 4, and don't forget about the plus 8. Alright, let's FOIL. Alright, for the first expression, we're going to get 3x squared negative 12x and negative 5x is negative 17x plus 20. Alright, 2. I'm going to FOIL these expressions first and then multiply by 2. Alright, FOIL that. X plus 3 times x minus 4. So we're going to get x squared minus x minus 12. Here again, don't forget about that plus 8. That gets carried along for the ride now. Alright, let's see. Keep cleaning up. I'm going to distribute that 2 now. So let's distribute the 2. So you're going to get 2x squared minus 2x minus 24 plus 8. Let's write that down. Alright, we're going to combine like terms, and I'm going to end up with 2 solutions here because this is going to be a quadratic. Hopefully it'll factor. If not, you have to use complete in the square or the quadratic formula. Alright, so let's combine like terms. So I'm going to subtract 2x squared and get it with x squared. I'm going to add 2x, gives me negative 15x. Alright, combining like terms, this gives me a negative 16. So I'm going to add that to 20. So negative 16 plus 20 is 36. Alright, so now we need to factor. Let's factor what multiplies to give us 36, but adds to give us negative 15. So negative 12 and negative 3. So when I factor this, I'm going to get x minus 12, x minus 3 equals to 0. Alright, zero product property. I got x minus 12 equals to 0, and x minus 3 equals to 0. So x is equal to 12, and x is equal to 3. Alright, now we need to check to make sure both of those work. So let's go back and look at our original equation. What was the restrictions on our domain? Make sure we didn't use any of our restricted answers. So I'm going back to look at this. Restrictions on my domain. So my denominators cannot be 0. So that means x plus 3 cannot equal 0, so x cannot equal negative 3. And x minus 4 cannot equal 0, so that means x cannot equal positive 4. Alright, are either one of those one of our solutions? Nope, looks like we're okay. If we'd had a negative 3, it wouldn't have worked, but we have a positive 3. So that means we have both solutions, 3 and positive 12. All right, don't forget to check these for extraneous solutions because you can end up with extraneous solutions in these circumstances. All right, here's another example. All right, so write this one down. So we need to find the least common denominator. All right, notice in that we have x squared minus 16. That's going to need to be factored. So let's do that. We find our common denominator, least common denominator. So I'm going to make this 6x squared. All right, let's factor. That's going to be x minus 4, x plus 4, minus 3x over x plus 4 equals 4 times x minus 4. All right, let's think about restrictions on our domain. So that means x minus 4 cannot equal to 0. So that means x cannot equal to 4. And x plus 4 cannot equal to 0. So that means x cannot equal to negative 4. So when we find our solution, we're going to go back and make sure we can't, or not one of our restrictions. All right, so what's the least common denominator? Hopefully you said x minus 4, x plus 4. All right, next step, what are we going to do? And here again, hopefully you said we're going to multiply everything up there by that common denominator. All right, I'm going to erase this because I need to get this out of my way so I have some room. But keep in mind, let's put this right there somewhere else to remind us that x cannot equal 4 and x cannot equal negative 4. So don't forget about those restrictions. Okay, so everything gets multiplied by our common denominator, which is x minus 4, x plus 4. All right, simplifying time. What do we have left? So here we can, so we're left with 6x squared minus 3x times x minus 4. And 4 times x plus 4. All right, let's solve this equation. Here again, notice that it's a quadratic x squared, so I'm looking for two solutions. All right, so 6x squared minus 3x squared plus 12x. I just distributed my negative 3x. Distribute my 4. I get 4x plus 16. All right, it's quadratic, so I need to get everything on one side. Combine like terms. So I get 3x squared. Subtract 4x, that's plus 8x. And subtract 16. All right, now I need to factor that expression. If you need a moment, pause the video and factor that expression. All right. When you factor it, you should have gotten 3x minus 4 times x plus 4 equal to 0. Right, zero product property. So set each factor equal to 0. Solve for x. So x is equal to 4/3. X is equal to negative 4. Don't forget about check your restrictions. See if anything doesn't work. Let's go back up. Well, our restrictions were 4 and negative 4, and we got negative 4. So that's making this one extraneous. So our only solution is 4/3. So make sure you look out for extraneous solutions. It's going to be restrictions on your domain. It's going to be extraneous solutions. Here again in class I will go over the calculator command so teach you how to check this by graphing. Here again you can always plug it back in to make sure that it works. Alright. I'm going to give you a couple more examples. If you would like some more practice, then you can continue on with the video. If not, you can pause it here and you can come back to it later. You're at least responsible up to this point as part of your notes. Alright, here's another, let's look at this problem. Here's another example. So here again I'm going to factor this expression. So I've got 8x squared over x plus 3, x minus 3, minus 4x over x plus 3 equals 2 over x minus 3. So that's going to make my common denominator x plus 3, x minus 3. So I'm going to go through and multiply all of my expressions by that common denominator. Alright, take a moment and catch up. Here again, like I said, anytime I'm going too fast in the video, please pause it. You can play catch up. Alright, let's simplify each expression. So this is going to leave me with 8x squared minus 4x times x minus 3 equals 2 times x plus 3. Alright, now it's Algebra 1. Quadratic, we're looking for two solutions. Let's distribute the negative 4x. Distribute the 2x. I'm sorry, the 2. Combine like terms. Alright, since we're solving an equation, notice I have a GCF of 2, so I'm going to divide everything by 2. Alright, let's factor. So what multiplies to give you negative 6 and adds to give you 5? If you need to, pause the video so you can factor this. So hopefully you got the following factors. 2x minus 1 times x plus 3 use your zero product property, set each factor equal to 0. So I'm getting x equals 1/2 and x equals negative 3. Alright, let's go back and look at those restrictions. Try to do that at the beginning, but like I said, somewhere in there you got to look at those restrictions. So let's go back to the original equation. Make sure you go back to the original equation when you're looking at the restrictions. Going back to this. Alright, so that means x plus 3 cannot equal 0, so x cannot equal negative 3. And x minus 3 cannot equal to 0, so x cannot equal 3. So those are restrictions on my domain. I can't have negative 3 or 3 as one of my solutions. So what does that mean? That means negative 3 is out. So my only solution is 1/2. You may not always end up with an extraneous solution, but please check to make sure. Okay, ask questions in class.